So, last thing we need to be able to do in this chapter is going back to our radicals and rational exponents again and looking at actual equations with these kinds of terms in them and trying to solve these equations. So we started out the chapter by looking at what does it mean when we have these different radicals or different rational exponents. How do we evaluate it? How do we figure out what that's equal to? And then we kind of shifted into this idea of being able to create new functions by doing different things like operations and compositions and inverses. And then we came back again to the radicals and said, all right, so now that we know that square root is really just the inverse of quadratic and cube root is really just the inverse of cubed, here's how we can graph them. Here's what the graphs are going to look like. So now that we know how to graph with radicals, we also need to know how to solve equations with radicals. So that's kind of our final step for this chapter. So let's take a look at an example. So let's say you have something like this as an equation that you're being asked to solve. So on the left side, we've got the cube root of the expression 2x plus 7. And then we're saying that that's supposed to be equal to 3. Okay? So let's just go with our gut for a second. What's your gut tell you should do first?
Cube both sides.
Cube both sides? Does that seem reasonable?
Yes.
Yeah, because now that we have this idea of inverse functions, we should have this understanding that cubing and cube rooting are inverses of each other. They're going to undo each other. Squaring and square rooting, okay? That there are these functions that as inverses are a way of undoing each other. That's where that verifying kind of came in, where we took f of g of x and found out that when we do that with two functions that really are inverses, they just cancel each other out and you're left with x, right? So there's this idea of inverse functions being able to cancel each other out. So if I'm taking something and cube rooting it, the logical way to get rid of that is to cube it. But we know from years of solving equations now that whatever I do to one side, I have to do to the other. So if I'm going to cube the left side because of the cube root, I also have to cube the right side because that's how equations work. So that's going to give me a 2x plus 7 on the left. My cube and my cube root are going to cancel out. And that's now going to be equal to what? 27. So now I've changed my radical equation into just a linear. And now it should be easy to solve from there. Subtract the 7. 2x would have to equal 20. Divide by 2. And so according to this, x should equal 10. But here's kind of the funky thing with radicals. Radicals have restrictions to them, right? Generally speaking, we cannot take the even root of a negative, for example. Okay? Or when we're just evaluating roots that have even indices, evaluating always just looks at the positive answer. If I take roots as part of solving, I look at both positive or negative. But if I'm just plugging something back in and trying to figure out the answer, that's evaluating. And evaluating almost always focuses on the positive answer. So there are some restrictions as to what can and cannot happen when we're dealing with roots. So the fact that I've turned this root into a linear and then basically solved the linear gives me a possible answer, but it may not always necessarily work. So it's really, really, really important that we take a minute and double check that our solution really is a solution. Okay? So if I put 10 back in for x, in the original equation, will this actually all work out? Are we okay? 2 times 10 will be 20, plus 7, cube root of 27 really is just 3. That's what we said it was supposed to be equal to, so we're good. Now I feel confident that yes, my solution really is 10. But you have to realize it may not always be what it looks like, so you've got to be careful and do that check. Okay?
So let me, couldn't you also kind of make like 2x plus 7? It could also come out to negative. No, it can't. Just kidding. Just kidding.
And especially not with odd, right? If it's an odd root, we only ever get one answer anyway.
Jokes.
But if it was an even root, we would still only want the positive answer. Okay? Because evaluating it, sticking something back in and evaluating it, we only focus on the positive answer. Okay? So we have to keep that in mind as we start working through these.
So do we ever consider the negative answers for square root?
Not when you're evaluating. When you're solving, yes. If it's a step as part of solving an equation and you take the root of both sides, then yes, you need both positive and negative. But if it's just, I'm going to plug this back in now and see what I get for an answer, then no. We usually just look at, now, there may be the rare example where something about the directions they give you leads you to believe you're really more interested in the negative, but that's not very often. Okay, so the majority of the time, if you're just evaluating something to work out the root, if it's an even root, we're going to just go with the positive answer. Okay? All right, so when it comes to the actual steps here, we kind of compare this to what we just did. The first step is to isolate the radical or the term that has the rational exponent in it. In this case, I'll come back to this in a second, that already happened. The radical was on the left side by itself. There was no coefficient out in front of it. We weren't adding or subtracting anything outside of it. It was already isolated on the left side. But if it's not, that's the first thing we need to do, is to get that radical or that rational exponent piece by itself. And then once it's by itself, then we're going to take both sides to some power that is going to eliminate that radical or that rational exponent for us. So the power we decide to take it to depends on the type of radical or type of rational exponent we have to start with. And once we do that, usually that's going to get us to an equation that we can then easily solve, because it's just going to be a simple linear or a simple quadratic or something that we know how to solve from there. Okay, so those are kind of our 3 steps. Isolate that radical or rational exponent first, then raise both sides to the power that we need to eliminate that radical or rational exponent, and then solve the equation from there. Okay, everybody got that down? All right, so with that in mind, here are a few relatively simple equations. I want you to take a couple minutes and try all 4 of those right now, and then we'll talk about what kind of answers you got in a minute. But take a few minutes and try all 4 of those on your own first. I know this is going to block your problems for just a second, but I'll get it out of the way. I just need to get it opened up. Damien, what's the first thing we should do on this first equation?
We move the negative 9 to the right side.
And how do I move it?
Change the negative to positive.
Okay, so we're going to add the 9 to both sides because we need to get this radical isolated. Right? The minus 9 is outside of the radical, and so we need to get that moved over so the radical becomes all by itself. And a positive 9 with a negative 1 becomes 8. Okay? Then what's our next step?
Cube the both sides.
Cube both sides, because that's the power we need to raise a cube root to in order to eliminate it. So if we cube both sides, x then is going to end up being equal to what? 512. Does that really work? If I take the cube root of 512, we'd get 8, then take 8 minus 9, really does give us negative 1, so yes, that's all good. This really should be my answer. Okay? Emma, what's the first thing I should do for this second one? Okay, because at this point, we already have the radical isolated, right? So, I'm going to the second step, which is to take both sides to whatever power is going to get rid of that radical. So if it's a square root, there's no other number there to tell us any differently, so it's a square root. We need to square both sides to get rid of it. So what should my next line look like, Emma?
X plus 25 is 16.
And then my last step,
Just subtract 25.
so x is going to be what? You agree? Does it work? Yes. Getting a negative answer when you're dealing with radicals is not necessarily the issue. It's what happens when you put the answer back in that could cause an issue. But if I put negative 9 back in for x, the negative 9 plus the 25 is going to give me 16, and the square root of 16 really is a positive 4, so it's all good. Okay? Now, what if, let's do a little what if here for a second. What if this had been a negative 4? When I squared both sides, how would this line change? It wouldn't, right? I would still end up with x plus 25 equal to 16, and then I would still subtract the 25 from both sides, and I would still end up with x equal to negative 9. But if I put negative 9 back in and take the square root of 16, the answer should be what? Positive 4, because at that point I'm evaluating the radical, not using it to solve something. So if this was the case, if this had been a negative 4 to start with, then we would have to say there's no solution, because negative 9 does not actually make this all work. Okay? All right. But it wasn't, so let me rearrange that. Whoa, hello. That's not what I want. Try again. Well, hello. That was
You
interesting.
click delete.
Let's do an undo here. There we go. Oh, here. Do that. Back to here. And draw these back in. And it's as if nothing happened. There we go. Okay? All right, next one. Our 2 times the cube root of x minus 3 being equal to 4. Whoops, hello. Sean, what should I do first on that one? Divide both sides by 2. Because we have this coefficient out in front of the radical, that means it's not all by itself yet. So we divide that off. End up with the cubed root of x minus 3 equal to 2 now, and then what? Cube both sides. So now x minus 3 should equal 8, and then finally, and I get x equal to 11. Does that really work?
Yes.
Yes, 11 minus 3 will be 8. Cube root of 8 is 2. 2 times 2 should give me 4. So this is all good. Oh, and I forgot to box this one, that this was okay. There we go. All right, one more color. Let's go red. Last one, a little bit different. Instead of dealing with a radical, we're now dealing with a rational exponent. So what should we do first, Cheryl?
First you should divide both sides.
Okay, so this, remember this exponent is only acting on x. The 4 is a coefficient out in front of that. So that means our rational exponent is not really isolated yet. So we need to divide by 4 to get it isolated. So that means x to the 3/2 power is going to equal what?
27.
27. Okay? So now we have it isolated. Now we're supposed to take each side raised to a power that eliminates the radical or the exponent. So what did you raise it to?
You square both sides.
Okay, does that eliminate the rational exponent for us?
Because I just think of x to the 3 over 2 power as the radical of x to the 3rd power.
So squaring both sides eliminates the rationalness of our exponent, but it doesn't actually completely eliminate our exponent, right? So squaring both sides is kind of half of the deal, but then we also have to do what? Cube root. So the beauty is, I could take care of all of that in one step. If I take both sides and raise it to the power of the reciprocal. Let that sink in for a second. Right? If I raise this to the power, let me change color here for a second, of the reciprocal, what's going to happen here when I take x to the 3/2 and raise it to the 2/3?
It's gonna turn into x.
It's going to turn into just x, right? Because what do we do when we take a power and raise it to another power? We multiply. So if I take 3/2 and multiply it by 2/3, the 2's and the 3's are all going to cancel out, and I just get 1, which means I'm just left with x. So multiplying by the reciprocal of whatever my rational exponent was to start with does that elimination for me that the second step said we were supposed to try to get. So this is just going to become x, and then on my right side, I just go about evaluating this like we did in the first lesson. What does it mean to have 27 to the 2/3 power? It means I take the cube root and then I square that. So the cube root of 27 is 3, and then 3 squared is going to give me 9. Now if you got to that same answer by doing it in 2 separate steps, you didn't do it wrong. If you just squared everything first and then took the cube root of what you got from that, that's fine. It's mathematically correct. It's all good. It's just this is a little bit sleeker because it gets us there in just one step. Okay, and is 9 really going to work? Yeah, we go back up here. 9 to the 3/2 means I take the square root of 9, 3, and then cube it, 27, and then multiply by 4, and we get the 108. So this is all good. Okay, so even when it's rational exponents, we still follow that same set of steps. We're going to isolate that piece first, and then we're going to raise it to a power, but the power we're going to use is actually just the reciprocal of whatever's there. Okay, and then evaluate it on the other side based on that new rational exponent. Okay? Questions on any of those? Okay. So what about this one? What's different about this one compared to the ones we were just doing? Yeah, so in the ones we were doing before, generally our variable was inside of the radical, and then we had it equal to some number. But now we're saying we want this radical to equal some other expression. So we're not just being equal to some number, we actually have 2 different x's going on. There's one that's inside the radical, but then there's one on the other side that's not inside the radical. Holy moly. But does it change our process? No. Our first step is still to get the radical by itself. Awesome, done. Right? It's over on the right side all by itself. Got it isolated.
Yeah.
Second step then is to do what?
We square both sides.
Square both sides. Take both sides to the power that eliminates the radical. So if it's a square root, squaring is what's going to eliminate it, and I have to do that to both sides. So the entire x plus 1 side is getting squared. And now what is x plus 1 squared?
X squared plus 2x plus 1.
Okay, so remember now, it's not just x squared plus 1. It's x plus 1 times x plus 1, which is x squared plus 2x plus 1. Make sure that you do that squaring properly. And what's that going to be equal to?
7x plus 15.
So my squaring gets rid of the square root, but I still have what was inside left to be equal to. So now what kind of an equation does it look like I'm dealing with? Quadratic. So now the solve it from there has to shift into quadratic mode rather than linear mode.
Oh, so you make it
So we get everything on one side equal to 0, and we see if we can factor it, and if we can't, then we go to quadratic formula, okay? So we just shift into quadratic mode. We know how to do it. It's just a little different than the linear we were doing in the previous problems. So if I subtract 7x over, we'll get minus 5x. And if I subtract 15 over, we'll get negative 14. So what do you think? Can I factor that, or do I need formula?
Factor it.
What would my factors be?
X minus 7
X plus 2.
So x should be
7 or negative.
but, good. But, do they both really work?
No.
Which one doesn't?
Negative.
Negative 2. Because if I put negative 2 in for both of the x's, here I get negative 14 plus 15, which is 1, and the square root of 1 is 1. But if I put it in here, a negative 2 plus 1 is negative 1. So, here's kind of that same thing I was talking about a minute ago. Once I've changed it into a quadratic, as a quadratic, there are two possible answers. But since what I originally had was a radical, they may not both necessarily work. Sometimes they do, awesome. But they may not, so I have to check. So negative 2 is not going to work. What about the 7? Does it work?
Yes.
Yes.
Yes, the 7 times 7 is 49. Add a 15 to that, we're going to get 64. So the square root of 64 is going to give us
8.
8. If I put 7 in here, 7 plus 1 will give us 8. That all works. So even though I ended up with two possible solutions, only one of them actually really works in the original equation. Okay? You can also check this graphically. So I just want to show you really quick what that would look like and why this is true. So what we're trying to say here is that we've got these two expressions that are equivalent, or we want to know for what x value these two are equivalent. So when I go to graph this, let's see here, graphs. Let me make this a little bigger. Zoom. X plus 1 is going to be one of my functions. That was what was on the left side. And then the square root of 7x plus 15 is the other expression. So what am I looking for to actually get the solution?
Intersection.
The intersection point. Do you see one at the moment? Nope. So let me grab here and bring it down. Now do you see one? Yes. But how many do you see?
1.
1. So there's only one possible solution. And to find out where that is,
0.
there it is at 7, 8. So 7 as an x value is the one that works, but the negative 2 that we got does not. And it's largely because this function doesn't even exist. Well, sorry, it does exist out here at negative 2, but it doesn't come down far enough to intersect with our other function at negative 2. So the only place we have an intersection is right there, so 7's the only So this is another way you could be checking yourself. If you wanted to just type both sides into your calculator and see where the intersection is, that works too. If you're not entirely confident about your arithmetic skills, you could throw them in and graph them quick. Okay? All right, let's take a look at one more. And then we'll give you a little bit of time to do some more. So what's going to be the issue with this one?
Oh, boy.
Everything's wrong with it. What are you?
Why don't you
No.
first put all the radicals to one side?
How do we apply this to overlay?
Sorry?
How would we apply this to overlay? I'm just wondering.
We need application
When do we ever apply this?
Next week, man.
This isn't
Well, I mean, if you think about it,
in our exam.
there are times where the only kinds of answers you can get are positive, right? Like in real life, theoretically you might be able to get positive and negative answers, but in real life it's like, no, I can only get positive. So there are, I mean, can I give you one off the top of my head? No. But it shouldn't be that big of a leap for you to go, yeah, I can kind of see where having to take the square root of something so that I only get positive answers kind of makes sense. Because in real life, most of the time, only positive makes sense. Okay? So, when we look at this, what's the first thing that causes us a problem?
The one.
The 1?
Yeah.
Why? Why is it causing us a problem?
Because if the one wasn't there, you can just square both sides and then
We'll be happy.
yeah.
Okay?
But now it's all gonna be messed up.
And so what was the first step we were told we were supposed to do?
Isolate.
Isolate the radical. Well, I've got more than one now. So it's pretty hard to isolate one of them without getting stuff with the other one. Right? Like I could subtract the 1 over and get the square root of x plus 2 isolated, but then I got negative 1 over on the other side. So when this happens, where you have more than one radical, and you are not able to get it to just one radical being isolated, then your first step has to shift a little bit to getting one of the radicals isolated. It may not be both of them, but get one of them isolated. And then raise it to the power that you need to get rid of that radical. So what power do we need for this? 2. Which means not only is this right side going to get squared, but so is this entire left side. Okay? Now, what you really have here is just a binomial, right? This is your first term plus this as your second term. So for just a second, imagine that this is just u plus 1 squared. Do you all know how to do that? Yes. We would take the u and square it. We would take 2 times u times 1. And then we would take the 1 and square it. Right? You're going to do the exact same thing. It's just that instead of u, you're going to be using square root of x plus 2. Okay? So, first term squared. What is square root of x plus 2 squared going to give me? X plus 2. Okay? 2 times first times second. What's that going to give me? Whoops. 2 square root x plus 2. Okay? Last squared. 1. And now that's going to be equal to 3 minus x. So again, the process that you already know how to do for squaring a binomial doesn't change. It's just a little bit more funky because our first term is this root. But it's still first root squared, first term squared, 2 times first times second, second term squared. The process is still the same. And now we've gotten down to just one root. So now we're going to go through the process again and say, all right, so let's get everything on one side and get that root isolated, and then work from there. So I've got an x here that I can subtract. And I've got 2, 3, so if I subtract 3 from this side, I can subtract 3 from this side. So it's going to leave me this 2 square root of x plus 2 on the left. The 3 minus the 3 is going to cancel out, and the negative x with another negative x is going to give me negative 2x.
Wait,
No, but
no, you don't do minus x, you get 2x because it's 3 minus x, so when you plus x, like
No, because I'm moving this one. I moved this one over because I'm trying to get this by itself. So I moved this x over to subtract it. The minus x I'm writing here is because I'm moving this one
okay.
over to that side.
But when you also be subtracting a positive x, it'd be negative 2x. Oh, sorry.
Yep, it is. I agree. Okay? So everybody see that? I'm moving this x over, not that x. So I'm subtracting the x to move this over. The 2 and the 1 here gave me a 3, so I'm subtracting the 3 to move all that over. So I just end up with this 2 square root of x plus 2 on the left side, and I'm left with a negative 2x on the right side. Everybody okay that far? Yep. Because that was the total of those two together, right? So my constant total on this side was a 3, so that's what I was subtracting. Okay? Okay, then what? Divide by 2 first to isolate the radical. So now we're talking about the square root of x plus 2 being equal to a negative x. Square both sides. So that's going to be x plus 2 equals x squared. Then what?
Make one side 0, so remove everything.
Okay, so now we can see, oh, I'm dealing with a quadratic, so we're going to get everything on one side equal to 0. Since x squared is already positive, I'm going to move it all to that side. What are my factors?
X minus 2, x plus 1, x minus 2.
So possibilities for x.
X minus 2 doesn't.
So if I put 2 back in, always make sure you go back to the original in case you made any steps along, or mistakes along any of your steps. So 2 back in here. 2 plus 2, 4. Square root of 4, 2 plus 1, 3. Put 2 in here. 3 minus 2,
1,
square root of 1.
1.
Wow, that didn't even come close, did it? Okay, so 2 is out. How about negative 1? Negative 1 plus 2,
1,
square root of 1
1,
plus 1.
1, 2.
And then negative 1 here. So 3 minus negative 1,
4,
4, square root of 4.
2.
So that one's okay.
Yeah.
So this one we can use, but positive 2's out. So does it take a few steps? Yes, this is a more complex kind of problem. It's going to take a little more work to get all the way out. But was any of that really hard? No, you had to be careful. I mean, that can be hard sometimes, is to just slow down enough to be careful. But it's not hard. The hardest part is right here, and like I said, it's not different from anything you already know. You just have to be careful that you're doing it correctly. Okay, and then just keep working it out until you get rid of all the radicals and you get down to an answer and check things out. Okay? Now you're not going to get a lot of this kind because this is obviously the most complex type of these problems that we're going to see. But you're going to get a couple, so you need to know how to handle them. Okay? All right, so we've got a little bit of time here. When you go to Canvas, you should see both. I suppose I should check this myself. I think it's up here. You should see both the assignment for 6-6. Canvas, right there. Algebra 2. All right, so we've got 6-6 homework right there. And then we've also got the Chapter 6 review right there, which has review problems and answers that you can work on. So you've got the specific practice for this lesson, and then you've got the review for all of the chapter to help you prepare for the test on Tuesday. And you've got until Tuesday to get it all done. We will have a few minutes at the beginning of class on Tuesday, so you can ask any questions that are still lingering. If you've got more than just 1 or 2 questions, then I would suggest signing up for a time on Friday, Monday, or Tuesday morning to get in and ask. Okay? But you've got a few minutes right now, so get some work done.
Just like amusement park.
Mm-hmm. Yes.
That is